In other news, so we have a twins paradox, right? The idea is, so if you go close to the speed of light, time slows down for you. And to be precise, this is not like you feel like time is slowing down for you. From your perspective, time has sped up for everyone else. Now this is rather crazy. Time is supposed to be the same for everybody. And things may seem to go fast or slow depending on like your mental state. If you fall asleep, for instance, time will go by very fast until you wake up. You know, while you were sleeping those several hours, though, you know, it's supposed to be constant, dang it, and apparently it's not. And then I heard even this one guy postulate that there are 2 dimensions of time. What the freak would that mean? I can understand multiple dimensions of space, not necessarily folded, but the general idea of extra spatial dimensions. What would an extra temporal dimension look like? How would you, like, go fast through one temporal dimension and slow down in another temporal dimension? I only know one time, guys. What is all this? I'm sure someday, 1,000 years or less than that, people will look back at me and be like, aha, it was so obvious. You know, just as people originally had the craziest time wrapping their minds around the idea that all the planets went around the sun and not the Earth. They're like, what the freak? It's right there. Look, there goes the sun. Woohoo! Around the Earth, right? Right? No, actually not. I mean, you could kind of say the sun goes around the Earth if you take your inertial frame of reference as being the Earth, but in that case, the other planets are still going around the sun. Anyway, so time dilates. So you get in a thing, and you go like near the speed of light. Other things will seem to go fast to you. So, like, if you had a pie, and you put the pie in the oven, and you want to eat it quickly, then you could just simply get into your spaceship, go at nearly the speed of light for a brief period of time, and come back, and then the pie will have already been cooked, because that hour has passed. Okay? By the way, the time dilation thing does not happen until you get really close. Like, you can go, like, a good 0.5 the speed of light, and you'd hardly notice. As far as I understand it. Like, it only matters once you get to, like, 0.9999999 or something. Maybe, like, 0.9 makes a difference. I don't know. Okay. So time is different. Different. That much you can kind of get. But then you start doing things with that, and it gets weird. Particularly when... Alright, so the reason this time thingy happens, or the reason we know it happens, is because everything in the world sees light as going at light speed. And by the way, light speed is apparently defined as light through a vacuum, which makes me wonder how they define a vacuum. Because what if there's something out in space, energy or whatever, that's messing with the light speed? Because like light speed apparently slows down when you put it through like water or something, and you can like actually kind of freeze light, kind of, in the proper laboratory, and then like send it off again. Okay. But besides that, there's the ultimate light speed, which light is supposed to travel at, and it's like the speed limit of the universe. And not only can you not get up that fast, but no matter how fast you're going, light always appears to be going at light speed. Right? So, what was it? Einstein originally imagined if a girl could run as fast as light, and she looked over to the side, what would she see? And somehow, he made the jump from that to light speed is as fast as anyone can go and time dilates because of it, or something. I don't know. I haven't quite got the jump there. The other thing they do when they try to explain this is the light clock. Have you seen this in museums? And they're like, see, imagine you got a clock, and it measures time by like zapping light back and forth. I'm like, okay. And then imagine that this clock is going near the speed of light, so then this light travels diagonally, beep, beep, and since it's traveling a greater path, then time has to go slower. Which makes me think, well, just get a new clock. You have an improper clock. That's like using a big pendulum grandfather clock inside a ship. You know, well, naturally, this ship's going to rock back and forth and throw off the clock. Get a different clock. What are you talking about? But apparently this is supposed to serve as a useful metaphor. So time slows down for you, and other things seem to go faster. So if you go like halfway the speed of light, and like there's a light beam going by you, you won't feel that, like, the light beam is going half its normal speed, even though the light apparently can go half its normal speed depending on the material it's encountering. But say it's in a vacuum, you'll see the light going at half its normal speed, you'll see the light going at its full speed. Okay, and this apparently happens because of the time dilation? I don't know if that's entirely because of the time dilation or what, but it would seem to make sense then that, oh, okay, so I'm going faster, time goes slower for me, so from my perspective, everyone else's time goes faster, things happen faster, when really you're taking the exact same amount of time, but time is different again, and so from my perspective, this light beam will also be going at the speed of light. Okay. This brings in, like, problems with simultaneity. What does it do, like, if there's a train going by and lightning strikes both ends of the train, and there's a guy observing this from the ground, and there's a guy in the train, and the guy in the train, I think, sees him hit simultaneously? Or does he? One of them sees it simultaneous, the other sees it not simultaneous, which brings the big question of what happened when. Like, things are supposed to happen, and it may be hard to, go and find out what happened, if there were, no witnesses to your lightning, for instance, but, like, one way or another it happened. It must have happened one way or the other. Like, no, actually, it could happen various ways, depending on your observer. And they'll almost say lightning A struck first, and then lightning B, and they'll be like, no, they struck at the same time. Wait, so which one struck first, then? It's like we're dealing with multiple realities, which leads into the whole deal of alternate universes, which, that would be interesting. Apparently they found some giant void in space. Put this up on faves.com. It was like, scientists find gigantic hole in space. Like, yeah, we don't know anything, do we? And then someone was arguing, I don't think it's mainstream, someone was arguing that this hole in space, it's not a hole, it's like this big section of nothing. Anyway, like, that is the imprint of another alternate universe or something. Okay. So then we get into just weird things. Twins paradox. Here's something I've wondered for a long time. How on earth does the universe distinguish between the twins? Because another part of relativity, the reason it's called relativity, is that everything is relative, right? There is no baseline. There is no set thing that this thing is not moving and everything else is. No. Anything is moving compared to anything else. It all depends on what you set as your starting point. Okay? Okay. So now wait a minute. From the perspective of the twin on the planet, the guy in the spaceship shoots away at near light speed, comes back, right? And because of this, we can expect that he will be rather young. He'll be nearly the same age as when he left, whereas the twin on the planet will keep aging, right? Because from his perspective, that guy shoots away at light speed and comes back. Okay,